Okay, still working on 18-1. We're trying to wrap our head around the angle-angle similarity postulate. Um, I wouldn't be really concerned with the why here, because that's not one, that's really not something that you're going to have to be responsible for answering on the test, but you will have to apply this knowledge. But I will run you through why real quick. Based on what's information is marked, we've got two pairs of congruent angles. And now that should be enough to prove that they're going to be, the sides are going to be proportional. So it says, based on the definition of similarity, explain whether transformations can show that ABC is similar to DEF. And I will argue real quickly that it will, because if you remember back on page 12, when we did this Venn diagram, we showed that all of the transformations that we did are good for proving or good for working with similarity triangles or similarity figures with similarity. Okay, the translations, the rotations, and the reflections, even though they maintain size, they don't change size, it is still considered similar because their scale factor is just a 1. Dilations are the only one that is a change in size. These are rigid motion, this is non-rigid motion, and there is a change in size, but yet it still maintains similarity. And the scale factor is the key there, because the scale factor, and we found it right down here on this one, when we found the scale factor to see how much bigger this one is than the original one, than the pre-image, what did we do? We took a side length from this one, and we took a corresponding side length from this one, and we made a ratio out of it. And the reduced form of that ratio is the scale factor. This is where it is vital that you be sure and you put the pre-image on the bottom and the image on the top. When we're over here working on just showing that two things are similar, it doesn't matter as much. But anyway, so we know that we can use dilations to prove similarity. And here's what we would do. We would find out, okay, I would take two side lengths, whether I have to measure them or whether I can calculate them in some way. I would find two side lengths and I would find my scale factor. AB, they're using AB. AB was a part of the pre-image, so they put that on bottom because we are dealing with the scale factor here, and DE is the corresponding side, so they put it on top. So whatever that number is, if you take that number and you multiply it times AB, you'll get the length of DE. So we're not gonna jump right to there, but that's basically it. So we're gonna take a triangle ABC, we're gonna perform this dilation with this scale factor, and that's gonna give us A prime, B prime, C prime. And then we're gonna be able to prove that this triangle is congruent to this triangle by angle, side, angle. We created it to be this side right here, the two sides to be congruent. And we know that angles maintain congruency through dilation, because we've worked example after example after example. And so we're able to prove, this thought process is able to prove that dilations will create similar figures. And all of this is just what I just said, so we're not going to bother writing it down. Okay, so now let's look at the difference between, and you have to be careful here. Okay, so is there a side angle side similarity? Now let's pay attention. They want us to compare the difference between this and this. Do you see the difference? It's very hard. So when you just see side angle side with nothing out behind it, it's understood, and maybe it shouldn't be, it's understood congruency. But how hard would it be to put side angle side in the congruent symbol? If you see side angle side and it has this similar sign after, then that's side angle side similarity. Okay, what's the difference between these two? Nothing in terms of the angles. The A still stands for a pair of congruent corresponding angles. That's what it stands for. And same thing over here, a pair of congruent corresponding angles. Okay, now these over here, when we're dealing with side angle side congruence, these two S's stand for a pair of congruent corresponding sides. And it's actually the same thing over here, another pair of congruent corresponding sides. This over here, these two S's stand for two pairs of proportional sides. So the only difference between side angle side congruency and side angle side similarity is the sides. Over here, if we're dealing with congruency, the sides are going to be equal in each triangle, and over here, they're not going to be equal, but they will be proportional. It says use geometry software to create those two triangles. All right. I guess we will use okay. I guess we'll use GeoGebra. It says we want AB to be 4. It's taking a long time. Okay, we're going to build a segment AB, and I am going to measure it so that I can see how long it is. Oh, I didn't do too bad. And now I'm just going to, oh, there it was. Change this until it's 4. Okay, so there's AB, that's 4, and now I need another segment, and it needs to be BC, and they want it to be 6, so let me measure it and see how long it is. Man, it doesn't look 4, does it? Looks longer. Okay, now it's 6. And the measure of angle B right here is 47 degrees. So I'm going to measure the angle. It's 47 degrees. Now I gotta keep it at 6. Uh-oh. I gotta keep it at 6. And I gotta make it 47 degrees. It's a little tricky. I hope you're trying to do this too. Oh, goodness. I knew it was going to be hard. 47. Come on, 47. I can't do it. It's somewhere right there. We're going to do 47.1. I got it. Oh, but look how long my line is. Oh, no. Can I shorten it without changing my angle measure? Nope, I can't. Okay. It's so hard. Okay, there's 6 again. I'm just going to leave it 46.9. It's not that different. Okay, so now it says do the same thing. We want D, E, so I'm going to do another segment, D, E, and they want DE to be 2. So I need to measure it and see how long it is. Oh, it's not close, not far. So DE just needs to be 2. Okay, there's DE to be 2. And EF, need another segment. EF needs to be 3. And let's measure it. So we need it to be a little bit, ooh, I don't know what that is. I don't know what that is. Okay, I messed up. So let's try again. Let's do segment EF. And now we're going to measure it. And it's 3.1. So I'm going to shorten it just a smidge. There we go. And they want the measure of angle E to be 47 also. So I'm going to get this, and it's 76. I'm going to swing it around to try to get it to 47. Oh, look at there. Oh, but it's no longer 3. I can't ever get them both the same. So leave it at 47 and just drag it straight down. Didn't happen, did it? 3, 66, 47.4. I'd like to get them both either 47. Oh, my word. Not even 3 again. This is hard. 47.3. I wonder if it'd be easier with my pen. I was using my mouse. Let me try my pen. Not easier at all. 46. Oh, looky there. I finally got that one. That was just a fluke. Okay, now it says, use the software to determine the remaining side. Okay, so maybe I can do this without moving anything. I'm going to put the remaining side up there, and let's measure it. Okay, that one's 4.4. Let's put the remaining side up there, and let's measure it. Okay, now notice that this side right here, DE, is half of 4, 2 is half of 4, 3 is half of 6. We made the triangle out of connecting the two sides. That one is 4.4 because it can't be anything else, and that one is 2.2. So we see that the scale factor, if this is my pre-image and this is my image, the scale factor was 1/2. It got half as big. We got the same angle measure here. Now let's measure the other angle measures. So let's find our angles. Let's do this one. It's 91.2. Let's do this one. It's 90.9, but remember this angle is a smidge off with this one. So they're very, very, very close. Let's do another one. Let's do this one. Oh goodness, I can't see it. I'm going to turn off C. It's not what I meant to do. I'm going to not show the label. There we go. That's 41.9. Let's measure this one. And that one is 42.1. So if I could manage to get, I wonder if it'd be easier now that I have all the other triangles. No, it won't even move. So Now that there, you can see that if these two had been the same, then these would have been exactly the same. So what did Springboard want us to do now? Use the software to determine, are the triangles similar? Yes, they are similar because all the sides are proportional and the angles are congruent. Based on your answers above, state the side angle side similarity. And the side angle side similarity is if two pairs of corresponding sides are proportional. Now, here's the other important piece. And the included, you got to be careful here, the included angle is congruent, then the triangles are similar. Now, it has to be the included angle. So, in other words, if you have this triangle and you have this triangle, and you know this side is similar to this side and this side is similar to this side, then it has to be these two angles that are congruent. It has to be the included angle. It can't be this angle is congruent to that angle. It has to be the included angle. Okay. What you're going to find out, the side similarity works the same way. If we go to the software and we draw all three sides that are proportional, then if all three sides are proportional, then the angles are going to be congruent. And so there is a side angle side and a side and an angle similarity. So I don't want to go through all of that again. I'm already 17 minutes in. So for congruency, you have side angle side, angle side angle, and angle side. For similarity, you have side angle side, and angle. Oh, and this one over here, you also have right hypotenuse leg. Okay, so you have 5 things that you can use to prove triangles congruent. You have 3 things that you can use to prove triangles are similar. And it says for each pair of triangles, write the similarity criteria, if any, that you can use to show that they're similar. Okay, so here we go. I only know one angle over here. So regardless of what I may know about the sides, because I don't know either one of these angles, this one right here is going to be none. I have to have, oh, wait, no, I don't. That's not true. I can use side angle side. And we would say, okay, so this side, 5 is proportional to 10. 5 is proportional to 10. So we'll mark this one right here. And that's the same ratio as 9 is to 18. And I can prove that because they both reduce down to what? 1/2. So this triangle is half as big as this one. Okay, and then between the two sides and this side right here, I'll double mark it. This side right here, I'll double mark it. And then because the angle that's between the two sides that we know, since the angle is between the two sides that we know, this is an example of side angle side. Okay. This one is also side angle side. You've got a side, you've got an angle, and you got this side is proportional to this side, and this side is proportional to this side. And so it's 9/6 is equal to 9/6, and the included angle is 90 degrees, so this one is also side angle side. And this one, all we have is that this side is congruent to that side. And that's a congruency. It could be but this side is not congruent to that side. So that means that these two are not proportional. These two sides are congruent. So that would mean that their scale factor is 1. These two sides are not congruent. So that means these two sides have a different scale factor. Therefore, they are not similar. Okay, so that is the end of this video. I will do one more video and show you the answers to these problems. I'll be back.